Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Allahumma salli ala sayyidina wa maulana Muhammadin wa ala ali sayyidina wa maulana Muhammadin wa barik wa sallim. Assalamu alaikum dear students. Today we will discuss a very important topic, that is our resistivity. Dear students, before starting the topic, you must know about the resistance. Then after this we will discuss the resistivity. What is the resistance? Generally we say that a resistance is the hindrance for the flow of current. In other words, we can say that it is the fundamental property of a material that determines the opposition or hindrance for the flow of charge or current in the material or conductor. Resistance causes the voltage drop across the material or electrical component by restricting the flow of current in that material or electrical component. Now we will discuss the factor which can affect the resistance of a material. Number one, the dimension of the material can affect the resistance. In dimension, the length of the material or conductor can change the resistance. Similarly, the cross-section area of a conductor can also affect the resistance or change the resistance of a material. Number two, the temperature. The temperature of the conductor or materials can affect the resistance. In conductors, by increasing the temperature, the resistance of the conductor also increases. By increasing the temperature of semiconductor materials, the resistance of the semiconductor material decreases. Number three, the nature of the material. In nature of the material, the configurations or the geometrical structure of the materials can affect the resistance. In simple words, we can say that the lattice structure or arrangement of atom in a material or the vibration of the atoms in a material can change or affect the resistance. So dear students, you must note few points. All the factors which affect the atomic structure of a materials like pressure, atmosphere, impurity and the frequency in the alternating current can change or affect the resistance of the material or conductor. Dear students, now we will discuss about resistivity. It is the intrinsic or inherent property of a material which remain constant regardless of the dimension or the shape of the conductor or material. The second thing you must keep in mind, it is the reciprocal of conductivity. The resistivity of a material depends upon the following factors. Number one, material composition. Number two, temperature. Number three, impurities and defects. Number four, electron mobility. Number five, crystal structure of a material. Dear students, now we will discuss about the resistivity of a conductor or wire. Before starting this topic, you must keep in mind the current is a flow of electron. Electrons or current have to face the resistance or hindrance. Resistance of a conductor is depends upon the number of collisions with the atoms of a conductor and with the other electrons, free electrons. We can write it as the resistance of a conductor is directly proportional to the length of a conductor if cross-section area of a conductor is kept constant. As resistance and length are directly proportional, this means that if we increase the length of a conductor, its resistance will also increases. If we double the length, the resistance will also be double. If we half the length of a conductor, the resistance will also become half. Actually, by increasing the length of a conductor, we have increased the number of atoms present in a conductor. So, when the current or electron passes through a longer conductor, there would be more collisions. Due to more collisions, more resistance is faced by the electron or current. So we can say that the length of a conductor is directly proportional to the resistance. More is the length, more are the number of atoms, and more are the number of atoms, and there will be more collisions, so more resistance would be offered by the conductor to the flow of current. So our first equation is resistance R is directly proportional to the length of a conductor. In this diagram, let's suppose the first wire has a length L, its cross section area is A, and its resistance is R. Now if we double the length is 2L, but the cross section area is same. By doubling the length of a conductor, the resistance now become 2R. The resistance will also be double. Why it is double? Because the number of atoms present in a conductor now double. So the collisions with the atoms has increased or doubled. This double the resistance of a conductor. Now we will discuss the second factor. The resistance of a conductor is inversely proportional to its cross section area if the length of the conductor is kept constant. Dear students, if you look at the diagram, we have a conductor or wire, its length is L, its cross section area is A, and its resistance is R. In the second diagram, the length of the conductor is kept constant, that is L, but its cross section area is double, it is 2A. As resistance and cross section area of the conductor are inversely proportional. Inversely proportional mean if we increase the one quantity, the other quantity will decrease with the same ratio. This means that if we double the cross section area, the resistance will become half. So now its resistance would be 1/2, half R, 0.5 R. If we half the area, the resistance will be double. We will discuss an example. This is only for understanding. Dear students, keep in mind, if we increase the cross section area, by increasing the cross section area, we provide more path for the flow of electron or current. So the electron can easily flow if they have more path for their flow. To understand this, we will discuss an example. In this example, we have three diagrams. In first diagram, let's suppose there are two atoms and the gap between the two atoms is 1 millimeter. So whenever the electron try to pass, the distance or the gap is 1 millimeter. In second diagram, we have increased the cross section area, so the number of atoms present in the cross section area has increased. Let's suppose there are 3 atoms. As in example number 1 we have discussed, the gap between two atoms is 1 millimeter. So there are two gaps. First gap, this is 1 millimeter, and the second gap is also 1 millimeter. In the third diagram, we have four atoms. Now the gap are 1 millimeter between the first two. Second and third atoms, there is another gap which is also 1 millimeter, and the gap between the third and fourth atom is also 1 millimeter. So the total gap now is 3 millimeter. In the third diagram, the gap is 3 millimeter. In the second diagram, the gap is 2 millimeter. In the first diagram, the gap is only 1 millimeter. If we find out the ratio between the gap and the atoms in first diagram is 1 by 2, that is 0.5 millimeter per atom. In second diagram, now the ratio become 2 by 3, which is 0.66 millimeter per atom. Now the gap between the two, the average gap has increased from 0.5 millimeter to 0.66. In the third diagram, there are four atoms, and now the ratio is 3 by 4, which is 0.75 millimeter per atom. Now, by increasing the cross-section area, the average distance between the atoms also increases. When there is a more path for the flow, more gap, distance or path for the flow of current, so the resistance will be less. Why it is less? Because due to more path, there will be less number of collisions. The number of collisions between the electrons and the atom now decreases. Because there is a more gap, the electron can easily pass through that gaps. This decreases the number of collision, so the resistance will also decreases. Finally, we can say that by increasing the cross-section area, the resistance of a conductor decreases. This is our second equation. Now, if we combine equation number 1 and 2, the first equation was R is directly proportional to L. The second equation is the R is inversely proportional to area. So by combining these two, we have R is proportional to L over A. Now if we change this proportionality sign into equality, for this we need a constant. Now we can write it as R is equal to rho. Rho is a symbol used for resistivity. Rho is a resistivity of that conductor. So R is equal to rho L over A. This is a formula to find the resistance of a conductor. If we know the length of the conductor, cross-section area, its cross-section area and resistivity of a conductor. From this formula, if we want to find the resistivity of a conductor, which is the rho will be equal to R into A cross-section area, resistance into cross-section area over length of the conductor. So rho is equal to R into A over L. This is the formula to find the resistivity of that conductor. Now the SI unit for resistivity from this final equation, from this formula of resistivity, the resistivity SI unit would be resistance is measured in ohm, and we also know the unit SI unit for area is meter square, and SI unit for length is also meter. So this meter is cancelled out with the square. Finally we have a ohm meter. So the SI unit for resistivity is ohm meter. Dear students, keep in mind the resistivity of a conductor remain constant as it is the inherent property of a material. So if the material is same, the resistivity of that material will also be same. Now if we want to define the resistivity, the resistance of a conductor or material for unit length per unit area. Dear students, if length and cross section area is given, we can find the resistance of the conductor by using formula R is equal to rho L over A, where rho resistivity of a conductor will also be given. But if instead of cross section area of a conductor, radius or diameter is given, as we know that the formula for cross section area is pi r square. So if the radius r is given, then from the radius we can find out the cross section area. We can find out its cross section area by using formula A is equal to pi r square. But if the diameter is given, we can find the area, cross section area, by using the same formula pi r square. We know that the radius is d diameter over 2. So by putting the value of radius in this formula, we have A is equal to pi d over 2 square. So the area is pi d square over 4. If the diameter is given, to find its cross section area, we will use this formula pi d square over 4. But if the radius is given, we will directly use the formula area is equal to pi r square. By putting the value of area in the formula R is equal to rho L over A, we can find the resistance of a conductor. Dear students, now we will solve an example. Let's suppose a conductor has resistance 4 ohm if its length is 2 meter and its cross section area is 0.4 meter square. What is the resistance of same material wire if the length of the wire is now 4 meter and its cross section area is 0.2 meter square? We have to find the resistance of a wire of same materials which has a length 4 meter and its cross section area is 0.2 meter square. Dear students, the first values we will use to find the resistivity of the material. As we are using the same material, so the resistivity will be constant. To find the resistivity, we use the first information given in the statement. The formula for resistivity is rho is equal to R into A over L. So by putting the value of resistance is 4 when its cross section area is 0.4 and its length is 2 meter. So our final answer is, our resistivity is 0.8 ohm meter. First we have calculated the resistivity, which is a 0.8. We will use this value of resistivity to find the resistance of the wire of length 4 meter and cross section area 0.2. So to find the resistance, we have the formula R is equal to rho L over A. By putting the value, the resistivity is 0.8. The length is now 4 meter. The cross section area is 0.2 meter. So by solving this, we have a final answer 16 ohm. Dear students, to solve the MCQ questions, we use a logics. As we have discussed that the resistance of a conductor is directly proportional to the length and inversely proportional to its cross section area. Dear students, now we will solve it by ratio method or logically, which we use specially in MCQs. As the initial resistance is 4 ohm when the length is 2 meter and its cross section area is 0.4 meter square. Now we have double the length. By doubling the length, the resistance and length are directly proportional, so its resistance should also be double. If we have a length 4 meter, its resistance now become 8 ohm. And the next thing, the resistance of a conductor and its cross section area are inversely proportional. If we look at the value of its cross section area, now the cross section area is half. The length is 4, the cross section area is now 0.2 meter square. So when we half its cross section area, its resistance will again double. So it becomes 16 ohm. So logically we can solve this question, especially in case of MCQs. Our answer is same as we have calculated by using a formula. Dear students, other formulae which we use to solve the question, if the diameter or the radius of a conductor is given. Now dear students, if we have to find the resistance of the conductor of same material mean its resistivity is same, constant, right? But the length and cross section area have changed. If instead of a cross section area, the radius or the diameter of a conductor is given, then we use these formulae to solve the question. We use this ratio formula. The ratio between R1 over R2 is equal to L1 over L2, where R1 is the initial resistance of a conductor and R2 the final resistance we have to find. L1 is the initial length and L2 is the new length, into, if we are using a cross section area, then we will write A2 over A1 if the cross section area is given. So we can also solve the above question by using this formula. Let's see what would be our answer. In the previous example we have solved. Initial resistance is 4 ohm, initial length is 2 meter, and initial cross section area is 0.4 meter square. Now the new resistance we have to find. The new length L2 is now 4 meter and new cross section area A2 is 0.2 meter square. So by putting these values in the formula, we have 4 over R2 is equal to 2 over 4 into 0.2 over 0.4. So by solving this, we have 4 over R is equal to 1 over 4. By cross multiplication from this, R is equal to 4 into 4, 16 ohm. As the material is same, so its resistivity is constant. In the above example, first we have calculated the resistivity, then that resistivity we use to find the resistance of the conductor if the length and cross section area has changed. But by using this formula without calculating the resistivity, we can find the new resistance if the length and cross section area has changed. Dear students, the same formula can be used if the radius or diameter of a conductor is given. In case of a radius, we use this formula as R1 over R2 is equal to L1 over L2 into R2 square over R1 square. R2 is the final radius and R1 is initial radius. As resistance and area are inversely proportional, so we will write the ratio R2 over R1, R2 square over R1 square. But if the diameter is given, for diameter we use this formula as the ratio between R1 over R2 is equal to L1 over L2 into D2 square over D1 square. As we know that the formula for area is pi R square. In this formula, the radius, there is a square of radius. Similarly, if we have a diameter, we have to take the square of the diameter. So these three formulas will help us to solve the questions if the material is same, cross section area are given, length is given, and radius or diameter is given. Dear students, there is another example. The statement of the example is given on the left side. The answer, the solution of the example is also shown. In this example, simply we have to find the resistance if the length, cross section area and resistivity of the conductor is given. In second part, the material has changed. By changing the material, the resistivity of new material will also change. Part second, the solution is also given. Dear students, now we will solve another example. The statement of the example is given on left side. The statement is a copper wire of length 1.5 meter and its diameter is 1.2 into 10 raised to power minus 4 meter, has a resistance 2 ohm. Determine the resistance of the copper wire with a length of 2.5 meter. If the diameter is kept constant, that is 1.2 into 10 raised to power minus 4 meter. So now we will use this formula. R1 over R2 is equal to L1 over L2 into D2 square over D1 square. So putting the value in this formula, we have initial resistance is 2, new resistance we have to find, initial length is 1.5 and new length is 2.5, and the new diameter is 1.2 into 10 raised to power minus 4 square over 1.2 into 10 raised to power 4 minus 4, 1.2 into 10 raised to power minus 4 square. As the diameter is constant, so diameter is cut down, so our final resistance is 3.33 ohm. Now in the second part, if the length is now 1.5 meter and its diameter is 2.4, 10 raised to power minus 4 meter. Again we will use the same formula. In this formula, now let's solve this part. We use the formula R1 over R2 is equal to L1 over L2 D2 square over D1 square. Now by putting the value, the initial resistance is 2 over R2, the initial length is 1.5. As the length is kept constant, in this example the length is same, so the new length is also 1.5, but the diameter has changed. The new diameter is 2.4 into 10 raised to power minus 4 का square over 1.2 into 10 raised to power minus 4 square. Dear students, length is cut down. Now if you look at the diameter value, the new diameter is 2.4, 10 raised to power minus 4. The initial diameter value is 1.2 10 raised to power. So the diameter is double. So we can cut down it by S. This is 2. Finally we can write 2 over R2 is equal to 2 square is 4 over 1. From this, by cross multiplication, we have a resistance. Final answer is 0.5 ohm. Dear students, today we have discussed the resistance, resistivity, the differences between the resistance and resistivity, the factor on which the resistance and resistivity depends. Then we solve how we can find the resistance of a conductor by using formula if the length and cross section area is given. Dear students, in next lecture inshallah we will discuss series combination of resistor and parallel combination of resistor. Thank you. Take care beta. Allah Hafiz.